Yes, today we will solve longest palindrome Leetcode problem. So we are given a string S, that's our input, which consists of lowercase and uppercase letters. That's an important info, so it's only letters. And for our output, we have to return the length of the longest palindrome that can be formed, that can be built with those letters. So this sort of depends into the input. First of all, what is a palindrome? So palindrome is a string that reads the same from both ways. So if I have Bob, for example, from left to right, we have BOB, and from right to left, we have BOB. So it reads the same uh, from both ways, and that makes it a palindrome. Next, we have an important piece of information that letters are case sensitive. So, for example, BOB, but uppercase B, because it's a name, will not be considered a palindrome. This is also a great first question to your interviewer. Are the letters case sensitive, and does this represent a palindrome? Let's go to an example. Here we have only A, B, C, D letters, and as you can see, they're of different frequencies. C is occurring 4 times, D is occurring 2 times, B is once, and A is also once. So our task is to take as many as possible letters from the input and form a valid palindrome. So as we can see here, the longest palindrome that we can form is of length 7, and this is the palindrome that we formed. So we took 2 D's, we took all C's, and we took only 1 A. And as you can see, we omitted B. B is not taken from the input. In the second example, we only have 1 letter, so the maximum that we can form is a palindrome of length 1, which we did, and 1 letter is always a palindrome because it's only 1 letter and reads both the same from left to right and from right to left. Now to the constraints, the maximum length of the string is 2000. And again, we reiterate the information that the string only contains only uppercase and lowercase English letters. So one brute force here is to take this input and permute it. So create all the possible permutations, and for each permutation, check if it's a palindrome. So when I say permutation, basically means I will put A in the first spot, then I will put B in the first spot, and permutate the rest. So like different orders of the letters, and like we will generate all the permutations and see if any of those permutation is a palindrome, and I will just record the maximum length while I'm generating the permutations. But that will blow up out of proportion because if we get an input length of 1000, like it would basically be impossible to calculate all the permutation in a reasonable time for an input of length 1000. So we have to do something else here. And the trick to this question is, and I wouldn't call it a trick because it's pretty straightforward actually. We have to consider the frequency of the letters and how can we use that frequency. And when I say that, we will just go through an example. Here we have the same example that we had from the problem statement, and I will just list all the frequencies for each of the letters that are appearing in the input string. So first of all, we have A that's appearing only once, B that's appearing only once, C that's appearing 4 times, and D is appearing 2 times. So the first thing that you have to note is that if you have an even count, that basically means that if you start from the middle, so if you start from the center, let's say this is an empty string, you can basically half the frequency, half the total count of, for example, C in this example, it's 4. So we can place 2 C's on left side and 2 C's on the right side. And even if we had, like, for example, 8 C's, we could just place 2 more on this side and 2 more on this side. And we can do the same for D because it's an even count. We can place D, so we basically half it and 2 divided by 2 will be 1. So we can place 1D here and 1D here to get the palindrome. As you can see, it reads basically the same from both sides. D, C, 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 C. And then from the left to right, it will be again B, D, and 4 C's and D. And now to the that's for the letters that have a even count. So we just basically split them. We to divide it by 2, the count by 2, and put one half on the left side and put the other half on the right side. And when I say half, it's just like an imaginary center here, an empty string, like it that divides the half. The thing that we can do for odd counts, let's say we have B that's appearing 3 times. In this case, it's appearing all once, but let's say our interesting case is to have it appearing 3 times. We can basically reduce it by 1, so -1, and we will get 2. So we have 2 B's and 1 extra B that we'll take care later. And we can do the same logic that you did for the even counts, letters with an even counts. So we will place 1 B on the left side and 1 B on the right side, and we will have 1 B remaining. So that's our 1 B is remaining that we cannot put on one or the other side, because that will make the palindrome, well, not a palindrome. We will have different count of letters on one side than the other. One special case here is that if we have at least one letter that has odd count, at the end, after we are done with putting halves of even counts on one side and the other side, we can take one letter, one odd count letter, for example A, and put it in the middle, because it will still remain a palindrome. Because if we do that, we will just have D, C, C, and then A, and then again C, C, D. So this will remain a palindrome because it reads the same. So that's one special case that we have to put. If we have one odd count letter, we can place it in the middle. So for example, if you have 3 B's, well, 1 B can go on one side, another B can go on the other side, and after we are done, we can place the remaining B in the middle, and we will still have a palindrome. So in this case, we basically just have to traverse the input. We have to count how many different letters we have. So we are basically building a frequency map. For each other, we will just increase the count as we encounter it, and then we go through the map, see we are only looking for non-zero counts, and then we apply the logic for even counts as we discussed here, and apply the logic for odd counts here. The last thing that we have to do is basically just see if we have any odd count, so we can increase the palindrome by 1. So we just get an extra 1 letter to the size of the resulting palindrome. Oh, now we are gonna code up the solution. First, we will check if the palindrome is empty. If the given input is empty, basically we cannot form a palindrome. But even by the problem statement constraints, we will be only given a string that's either of length 1 and above, but just for any case, like we can do the safeguard to check if the string is empty and returns 0, because we cannot form a palindrome that way. Next, we will create a frequency map. Now, for frequency map, you can choose a regular hash map, and which will have a ledger for the key, and the value will be just the total count of basically the frequency of that letter. But because we are only dealing with lowercase and uppercase letters, we can have a limited size array. We know that all the letters will map from 0 to 128. So we are basically having a constant space complexity. Next, we will go through the input string, and for each letter, we will just increase the corresponding element at the corresponding element at a certain index. So, for example, if we have A, we will just we will just increase the specific index that letter maps to. And because it's ASCII, we will have an implicit conversion from char to integer, because we are using char to index to index an array. Next, we will declare a total length variable that we will use to count what's the total length of the resulting palindrome. And we will also have a Boolean, which will serve only one purpose, and that's to track if we have at least one odd count letter. Next, we will go to the frequency map, and we will skip the 0 frequencies because those are letters that are not appearing in the input string. And for the letters that are not divisible by 2, so that have a odd count, we will just decrease it by 1, and the rest can be placed on left and right side, so it's forming a valid palindrome. For the letters that have a even count, we will just take all the letters, like all the count. Like if we have 4 A's, we will just take four A's. And then we will just see if we have at least we are just basically checking if the current frequency is odd count for one specific letter. And if it is, we will just set our Boolean variable to true. Next, we will return the total length, and we will just increase it in case we had at least one odd count letter.